So this is a wiki page, and if you can see, right, when I say edge detection and when you apply a filter, the entire image you convert it into something like this. Okay, this is called the edge detection. And that you can apply it on each pixel by multiplying this sum of these kernels, which are predefined. If you multiply it, then that helps you prominently in identifying the edges. Now the next part is this is what I was about to show, that in 5 we are multiplying these pixel numbers by this one, and you are getting the edges of this. And I didn't know that I already have an example. Then in the next layer, what we are doing is once these pixels are identified and the edges are identified, and then the various parts of the numbers are identified, we are connecting it and passing it to the various neural networks, our neural network, and that's when we are forming the entire number. So what happens is when a particular number gets identified in the edges, what you do basically is after connecting all these images together, the particular set of neurons get fired, which makes sure that in the output layer, a particular neuron gets fired, which correctly identifies the number which this image represents. So it is like a set of group of neurons comes together to form a number. Okay, but you need to also understand the same neurons might be used because this kind of line or this kind of line might be in other digit also. Someone might write a zero in a curved way also. Okay, so but this also could mean it is a part of another zero also. But in an overall, what happens in the next layers is you try to bring all these pieces together and form a certain set of neurons, which will give you a certain type of image. And towards the output layer, a particular neuron gets activated, telling us very clearly that I connected all these pieces together, and I could very well say that this is a number 5 actually. So that's what is happening into this entire process. And let's go back and let's define our model once again. Okay. So now that we have added the convolutional model, okay, we will now add another layer where we are doing the max pooling. And max pooling we will see very soon what exactly is the max pooling. And then later we are kind of flattening it. We are making it in one line. And then later, like I mentioned, um, we are flattening it. And then like I mentioned, we are adding another dense layer with an activation for function of ReLU. We are using it with 128 neurons. And finally, we are using a softmax function, which will give you probabilistic distribution based on what that number is there. Okay, if that number is 5, the neuron of 5 will get probabilistic value added. Highest number of probabilistic value will get added. So this is our model, and that's what we are going to implement it. So this got added. This is just a function at this moment. We are not used it. Then we are defining what should be our batch sizes and epochs. Okay, that's what we are defining here in the hyperparameters. And then we will do it is we will compile it. Okay, the compiling part includes three different areas. One is optimizer, okay, which is we are using as an atom. Okay, this if you would have seen my previous video where we are very clearly talking about how multiple algorithms we can use it for calculation of the gradient descent and how we wanted to tweak the data or weights for making it our prediction closer to what is the expected value. And we are using in this case Adam and sparse categorical entropy. We did discuss about all other algorithms also. Um, but for this kind of problem, we definitely need the sparse categorical cross entropy. And the optimizer we are using is an Adam. And how we are going to measure how the network got trained is using the accuracy. So I'm not sure whether I ran this, but yes, let's run this. I ran it. Then we are doing a model creation. We are just defining it here. Now, what comes is an actual model generation process. So what we are going to do here is we have added a the epochs only three I have added. Okay, batch size I gave 128. So 3 iterations on the entire data will happen during this process. And let's see the accuracy also. So currently it is running and there is an error it is saying. So let's see history model for training data set is not defined. So I think somewhere we would have missed the training data set. Yes, I did miss some 2 steps where we are defining the data loading strategy. Okay, where we are specifying how we wanted this data to be loaded. Okay, what is the batch size? And this is something I missed. So let's run about the training data set and how you wanted to update. You wanted to shuffle that data or you wanted to sequentially pass it. That's what you are specifying here. The same thing we are doing it for the test data set also. Do you want it to pass it the way it is, or you want it to shuffle, or how it is? Okay. Now let's, I think this part is already ran. Now let's try to run it. So first epoch started. Let's see how the accuracy comes. It is going so far. It is going good. Okay. So let's see how much far it goes. When I earlier ran, it was around 95%, but let's see how far it can go. So my accuracy when I ran very initially, it went to 98, 99% actually. And you need to look at it this number, okay, 98, which talks about the validation accuracy. This is the accuracy on your um, test data, sorry, on your train data, and this accuracy as well as the loss is on your train data, sorry, test data. And this is on a train data. That's what it represents. In the first cycle, you got somewhere close to 97, somewhere 98, 98, 31. So